Dear students, under the lecture series on complex analysis, here we are going to learn about differentiability. In our previous video lectures, we learnt about limits and continuity under complex analysis. As a continuation, we are going to learn about differentiability. If f of z is a complex function, then f of z is said to be differentiable at the point z naught if f dash of z naught exists. And what is f dash of z naught? It is equal to limit z tends to z naught of f of z minus f of z naught divided by z minus z naught. We shall understand this definition with the help of a problem. Now, in order to prove that a function is differentiable, we have to check whether this limit exists for that function. So now here we have a problem which says that show that if f of z is equal to xy square multiplied with x plus iy divided by x square plus y power 4, if z is not equal to 0 and 0 if z is equal to 0, then this function is not differentiable at z equal to 0. Now we have to show that this f of z is not differentiable. So now in order to show that it is not differentiable, we have to show that f dash of z naught does not exist. We know that a function is said to be differentiable if this, that is f dash of z naught, exists. Now here the question is to prove that it is not differentiable, for which we have to prove that f dash of z naught does not exist. So let us start the proof. So first is we have to prove that f dash of z naught does not exist. Now what is this f dash of z naught? It is limit z tends to z naught f of z minus f of z naught divided by z minus z naught. So let us take and write this. So now in order to show that the function is not differentiable, we have to show that this limit does not exist. So for that, first we shall prove that this limit does not exist. How we will be proving? We will be trying to prove that the limit is not unique, as we have seen under the concepts of limits. When we learnt about the concept of limits, we saw that in order to prove that the limit does not exist, we will prove that the limit is not unique. So here if you observe z naught, that is the point at which we have to prove that the function is not differentiable, is 0. So which means the value of z naught is equal to 0. So at this point we have to prove that the given function is not differentiable. So which means now here in this formula, if you substitute z naught as 0, because we know that z naught is 0. So how does the formula turn out to be? That is, we have to put here 0. So f dash of 0 will be equal to limit z tends to z naught. So what is z naught? It is 0. F of z minus f of z naught. So f of 0 divided by z minus z naught is 0. So now in this, if you see, we know that f of 0 is 0 because here when z is 0, f of z is 0, which means this implies that when z is 0, so when you put 0 over here, the value is equal to 0. So f of 0 is equal to 0. So therefore, when z is 0, f of 0 is 0, which means this value is 0. So this is equal to limit z tends to 0 f of z divided by z, because these values are 0, and so we get f of z by z. Now we shall substitute what is f of z over here. That is, we know that z is equal to x plus iy. So at the place of z we will substitute x plus iy. And what is f of z? It is given here in the question. So let us take and substitute them. And also, as z tends to 0, we know that this x tends to 0 and y tends to 0. So the limit z tends to 0 will change to limit x tends to 0 and y tends to 0, since these terms we are going to write in terms of x and y. So on substituting, this will be further equal to limit x tends to 0 and then y tends to 0. Now what is f of z? It is xy square multiplied with x plus iy divided by x square plus y to the power 4, and this whole divided by z, but it can also be written as multiplied with 1 by z, because denominator of the denominator. So this is actually divided by z, which can be written as 1 by, multiplied with 1 by z. But what is z? It's equal to x plus iy. So x plus iy, and we see that this x plus iy and this x plus iy gets cancelled, and we are left out with limit x tends to 0, y tends to 0, xy square divided by x square plus y to the power 4, since these two terms have got cancelled. Next, we shall choose a path in order to learn about the limits. Now, since here you have square terms, let us choose the path as parabola. Because if you choose a straight line, we will be, if, for example, if you consider y equal to mx, here in the numerator you will have x to the power 3. In the denominator you will have x to the power 4, and here you have square, so we won't be able to cancel the terms very easily. Because we have y square and y power 4 over here. Let us choose the parabola x is equal to my square. If we choose this parabola, and when we put at the place of x as y square, in the numerator also we will have y to the power 4, and in the denominator also we will have y power 4, and easily the terms can be taken in common and cancelled. And so let us choose along the path x equal to my square. So if you choose along the path x equal to my square, what happens to f dash of 0? So f dash of 0 will be equal to, so on applying here, so here x we have to choose as my square. So it will be my square multiplied with y square divided by, here you have x square. So when you square this term you get m square y power 4 plus y power 4 already we have here. And so therefore f dash of 0 will be equal to, in the numerator you will have m y power 4, and in the denominator you can take this y power 4 in common, and you will have m square plus 1. We see that y power 4 and y power 4 gets cancelled, and here the limit turns out to be, and here you will have limit x tends to 0. So the limit x tends to 0 of m divided by m square plus 1. And since you don't have any x term over here, the limit completely depends upon the value of m. So from this we see that the value of the limit depends, okay, so depends on the value of m. So as m keeps on changing, for example if m is equal to 1, what will happen? This limit will become 1 by 1 square is 1, 1 plus 1 is 2. If m is equal to 2, it will be 2 divided by 2 square is 4, 4 plus 1 is 5, so 2 by 5. So see, the value of the limit keeps on changing, since we have m by m square plus 1 over here. The value keeps on changing as m is changing. So as the value of m changes, and since the limit keeps on changing, we identify that the limit is not unique. So limit is not unique. So if the limit is not unique, we know that limit z tends to z naught of f of z minus f of z naught by z minus z naught is not unique, which means that the limit does not exist. So this implies the limit does not exist. So what is that actually? Here we have f dash of z naught. So we have proved that f dash of z naught does not exist. So f dash of z naught does not exist, which means that is at the point z naught equal to 0. So f of z naught does not exist at the point z naught equal to 0. So hence f of z is not differentiable at the point z equal to 0. So we will conclude the problem by saying that Hence, hence f of z is not differentiable at z equal to 0. This is what we wanted to prove. So hence it is shown. So I hope you would have understood how to show that a function is not differentiable. In our upcoming video lectures, we will learn more problems under this topic. Thank you.